Welcome to this video about parallelograms. We will define the parallelogram. We will present a couple of properties of parallelograms. Then we will move to calculate the area with a practical example. If you like this video, please subscribe to the channel and activate the bell button to receive notifications for the new videos. Now let's start. A parallelogram is a quadrilateral in which the opposite sides are parallel to each other. So if we considered this parallelogram ABCD, we notice that AB is parallel to CD, and we write this as AB is parallel to CD. Similarly, we have AC is parallel to BD, and we write AC is parallel to BD. Now, based on this definition, we will move to talk about some properties of parallelograms. The first property, the point M falls on the middle of each diameter. First of all, AD and BC are the two diameters of the parallelogram. Now, those two diameters meet in a point M. This point M splits each diameter into two halves. For example, it splits the diameter BC into two halves, BM and MC. Of course, we can write this as the length of BM is equal to the length of MC. Similarly, it crosses the diameter AD into two parts that have equal lengths, and we can write this as L, the length of AM, is equal to the length of MD. We call the point M the point of symmetry of the parallelogram. This means that for every point of the parallelogram, we can find a point on the same parallelogram that falls on the same distance of M, but in the opposite direction. For example, for the point B, if we draw a line that connects the point B with M, and if we extend it with the same length, we will reach a point C that falls on the same distance from M. Here we have the length of CM equals the length of MB. However, it falls on the opposite direction of M. So this applies for every unique point of the parallelogram. Similarly, for example, for point D, we can find point A that falls the same distance from M as the point D, but it falls on the opposite direction, and we have the length of AM is equal to the length of MD. Similarly, for any point, we can connect it to M and extend it with the same distance to get the point that is symmetrical to the first with respect to M. You can check my video, Line and Point Symmetry, in which I explained the concepts of symmetry and symmetrical shapes with respect to a point and with respect to a line. And I have included several examples. I will put a link to this video at the end that you can watch at your own convenience. So the next property here, each two sides that are opposite to each other in a parallelogram have equal lengths. So we have here AB and CD are two opposite sides in this parallelogram. They are parallel first, based on the definition of the parallelogram, and also they are equal in length. And we write this as the length of AB is equal to the length of CD. Similarly, we have AC and BD are two opposite sides in this parallelogram, and they are parallel to each other based on the definition of the parallelogram. They also have equal lengths, and we express this as the length of AC equals the length of BD. Now the last property, each two angles that are opposite to each other in a parallelogram have equal measures or equal sizes. So we have here, for example, the angle A is opposite to the angle D. So we write, for example, A and D are opposite. In the parallelogram, this gives that the size of A equals the size of D. And similarly, B and C are opposite to each other, so they have equal measures or equal sizes, and we write the size of B equals the size of C. So let's take here a simple test. We have BCDH, BCDH, and BCTD, BCTD are parallelograms. Prove that D falls on the middle of TH using the properties of parallelogram. So we want to prove this point D falls on the middle of TH in this shape we have here. So let's start with what we are given at the beginning. BCDH is a parallelogram, BCDH. This means that BC is parallel to HD, and based on the properties that we have already learned, they also have equal lengths. Now we move to the other parallelogram, BCTD. It's here, BCTD. Also in this parallelogram, we have BC is parallel to TD, and the length of BC is equal to the length of DT based on the properties. So we also have this. We conclude that D falls on the middle of the line or the straight line or the piece of line TH. Now let's take another example. Locate the 2 points C and D so that ABCD is a parallelogram where G is its point of symmetry. Since G is supposed to be the point of symmetry of the parallelogram that we are gonna form, this means that in order to find C and D here, we have to extend AG with the same distance that is equal, in other words, to the length of AG. So almost, we end at this point and we call it C. Similarly, we extend BG with the same distance. So here we have these two lengths are equal to each other. So we extend again BG with the same distance, and we end with the point D, where the length of BG is equal to the length of GD. And now we connect each two consecutive points. And we get this parallelogram ABCD. The area of parallelogram. First of all, let's learn about the concept of the height of parallelogram. The altitude or height of a parallelogram is the perpendicular distance from the base to the opposite side, which may have to be extended. In the parallelogram, we see on the right, the height is h. So here we have a parallelogram. Here it's called A, B, C, D. And then we draw a vertical line from the first base. Let it be drawn from point A on the other base in the parallelogram, the opposite base, we can say. So it meets with the base in point E. Now, in order to calculate the area of this parallelogram, we take a scissors and we cut this small triangle here at the end. Imagine that you are cutting it and removing it from its place. So you are no longer, you no longer will have this AEC, but you will have nothing. You will end with the edge AC as in here. Okay, where are we going to put this triangle that we have already removed? We will put it on the right side of the parallelogram we had at the beginning. So now we have BD here, the same. And we also have the rectangle, the triangle that we cut from here and we placed here. Now the area of this rectangle is nothing but the area itself here of the parallelogram. Why is that? Because we know if we want to calculate the area of this rectangle, then it's equal to the length multiplied by width. The length is EF multiplied by width, which is the length of FB. However, the length, which is EF, is nothing but the length of CD. Okay, because here we have ED, it's the same piece exactly, but we have removed CE from here and we put it here. So the length of DF is equal to the length of CE. So the length is the length of base of the parallelogram multiplied by width. The width here is nothing but h. Okay, we find here which is the height of the parallelogram. From this, we conclude that the area of the parallelogram, since it's equal to the area of the rectangle, equals the length of the base of parallelogram multiplied by h. Or in other words, if we want to conclude it from the first parallelogram that we have here, it will be equal to length of CD multiplied by h. Let's take a simple test. ADBC is a parallelogram, ADBC. The length of BC is 5. The length of AH is 3. And the length of AG is 3.75. Now, first of all, we need to calculate the area of the parallelogram. As we have just learned, the area of the parallelogram is equal to the length of the base of the parallelogram multiplied by the height. Here, the base is BC, let's say. So we need to take the length of BC multiplied by the height, which is here the length of AH. And this is equal to 5 multiplied by 3 equals 15 squared centimeters. And then the second question is calculate the length of CD. So here we can flip the area to be equal to the length of CD multiplied by the length of AG, that is now the height of the parallelogram. And here this gives us the area from the first answer is 15, is equal to length of CD, which you want to find, multiplied by the length of AG, which is 3.75. And this gives us the length of CD is 15 divided by 3.75 centimeter. Thank you for watching.